Valency of molybdenum is 42. Palladium I will show you, Kushi. Write it for molybdenum. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 10, 4p6, 5s2, 4d, 10, 20, 30, 38, 38, 4, right? So molybdenum DD transition agodrinda, it will be like this. It will get exchange. Electronic configuration alli exchange agutte. So it's of 4D. No, you can write ether and variable. No problem. So 4D, you have 5 subshells. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Ashte. This is a molybdenum structure. You have 4 unpaired. You are writing 4. Then you're saying I didn't get. Let me know the Kushi's problem. I'm filling 1 in. Yeah, Kushi, I'm feeling the same. What's your doubt? So you're asking me about the atomic number. It's 6. Palladium is Pd. Pb means lead. Last column is, it's kept empty. That is what you can write like this also. 1, 2, 3, 4, 5, right? So it's S is, instead of 2 electron, we can write like this also. We can write like this. But actually we need to write like this because this DD transition will occur half orbital filled. Palladium is Pd. Why you are confusing with palladium and lead? Yes, ma'am. That is what I meant. This is true. Actually, it's get DD transition. So when the electron or atom get DD transition, pair of electron will jump and it will become half filled. So that because to get unstable. Okay. Okay. No, not you, Kushi. 46, right? Let us write the electronic configuration for 46. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d, how much? 8. Okay. Okay. Then start now. Lead. That's PB, it's 82. Gagana, it's 82. Not Gagana, I think so. Who's asking like? Tasneem. Why can't we write a 4D10, man? 4D10, where you are giving? How can you give? See, 2 of its electron it won't give. If you balance halfly filled, half will also stable. So to make a half filled stable, this 5s is giving donating 1 of its electron. So but it required 2 of its electron to satisfy fully filled. So no one is giving. See, I have 2 rupees, I can give 1 rupee. If you are asking entire my 2 rupees means how can I give? I won't give anything. If my as a tends to give at least 1 rupee, but while you are asking to give 2 of it, rejected completely, I'm not giving anything. So that is a condition here. So if it is partially filled, that if it is getting 9 or 4 like that, it could have give 1 electron and it can be the halfly filled or completely filled. But it required 2 of its electron from the 5s. So that's why S, that 5s, it doesn't allowing its 2 of its electron to give it. Okay, during exams, we can write 2886 like this. Yes, you can write, but if they were asking for DD transition, you can't write. You should write like this. Better you practice like this because this is going with a basic. So if you are writing 28864 like that, how can you see? Suppose this DD transition actually in the zonal, in the like series we used to write 1s 2s 2p, so order after the other we used to write it in a zigzag way, right? First 4d will come, then 5s, but according to the DD transition is going to be exchanged. So if you're writing like that 2 comma 8 comma 8 comma 4, we didn't get that. Okay, so did you get it how to write this? This is 4 8, right? So 8 means to say 3 paired of electron with unpaired. That's it. Don't get confused. Go from the valence electron. Valence electron in the start ಮಾಡ್ತಾ ಬನ್ನಿ. So then it will be of easy to understand or easy to write. If you are thinking this and this, if you are moving like this, you didn't get. So go from the valence orbital. So first see whether does it contain any unpaired electron like single electron or not. If it's not, then go for the lone pair. Is that clear? Shall I move for the next topic? Ma'am, 3 paired and 2 unpaired. Yes, exactly. 3 paired and 2 unpaired. But if I wrote a point here, you think like this is paired. That's why I didn't wrote. Shall we move? Any doubt regarding the dot structure, because it's very important. Aita? Oh, okay, very good. See, I don't carry your doubts much because chemistry only doubt. What to say? Not understanding. Ulas, do one thing. This is like heavier. Okay, you just go with a simple one. First, start with the carbon. Okay, just starting with the carbon 6, oxygen 8, nitrogen 7. So go from the basic, like go from the little bit. Then you can go for the DD transition, because if DD you are trying to learn in the initial state, you'll get confused how to write this and all. Those who have like understanding in yesterday's class, they can get over it. Okay, if valency is 8 means to say it is stable. Not like that. It should be halfway filled. In the outermost orbital, I am saying, if supposed to be S, 1 is half filled stable, 2 is completely filled stable. It's supposed to be P having a 3 subshells. So 3 is half filled stable and 6 is completely filled. So based on the outermost orbital subshells containing, how many subshells it containing, Based on that, if it is halfly filled, that is also stable. If it is completely filled, that is also stable. It doesn't mean like 8 should be stable, 6 should be stable. It's not like that. It's completely depend upon the number of subshells present. Okay. Yes, Ulas, that is what my suggestion to tell you what to know, what to do for that. So you just go with the carbon, helium, lithium, sodium, nitrogen, oxygen kind of things. Start trying with DD transition because it will get confusing if you are going DD directly. Fine. So now we have formal charge. Okay, formal charge. So from this dot structure, we are going to write. How can we write dot structure for? Write the atom electronic configuration. Split the electronic configuration. Go for the valence electron. Does it containing pair or unpaired? If your unpaired electrons is there, first mention it out. Then go for the paired electron. That's it. Okay, next, formal charge means to say we are going to calculate a number of shared electron with the other atom. For example, I'm going to make water molecule. So it means to say it's a combination of hydrogen and oxygen. So what I need to do, just I'll write the dot structure of hydrogen and then I'll write the dot structure of oxygen. So I'll combine both the things. So now all together, I require that how many electrons are involving in their bond formation. Okay, I'm not talking in point of hydrogen or oxygen. So I'm talking in point of how many electrons are going to involve in the bond formation. So based on that, we can just say which type of bond is forming over there. Whether it is double bond, whether it is triple bond, or it may be a covalent bond or coordination bond. So you get it. So based on the how many bonds, how many electrons are involving, okay, in that we can calculate. So we doing covalent bond, covalent bond only. So we have one formula to calculate how many formal charge we have. Formal charge for an atom. So for that we have one formula. Write down the formula. This is formal charge. We are representing it in terms of Fc. Okay. So this is basically for Lewis dot structure. So Fc is equal to total number of valency. Okay, means to say free electron minus total of non-bonding electron. It means to say lone pair of electron, lone pair. So what do you mean by lone pair? These two. We are going to write the completely filled, right? When the orbital is completely filled, so this is called lone pair. So this type of electrons is not involving in the bond formation because it's already stable condition. Okay, so you need to write total number of valency. Valency means single electron. How many is there? That you should minus with the total number of bonding electron. Okay, that again you should minus with 1/2 of total number of bonding. It means to say how many electrons are going to share. Okay, how many electrons are going to share. So this is the formula. Okay, got it? So total number of valency means unpaired minus lone pair of electron minus 1/2 of the electrons that's involving in the bond formation. Formula ಕಾಣಿಸ್ತಾ ಇದೆ ಇವಾಗ. Can you see it clearly? And can you see completely the screen? Okay, fine. Fc is equal to total number of valency minus total number of non-bonding electrons, that is lone pair of electron, minus 1/2 total number of bonding. So for this calculation, I'll give you a simple thing. So after that, you can go with the further like big one. So just I'll write O3 structure. O3 means ozone structure. Okay, this will be like this. Is it right? It's in a triangular formation. So now I'll write the dot structure for all this oxygen. Okay, all three oxygen. Before that, I will go to give the name as oxygen number 1, oxygen number 2, and oxygen. Is it fine? Okay. Now, this oxygen having the atomic number. So first, generally, I'll write the electronic configuration for all the oxygen because all are seems to be same. 1s2, 2s2, and 2p4. So 4 means to say we have one lone pair of electron and two unpaired. Is that right? So what it will do? Two unpaired electron will bond over here. Okay, and here one electron will bond with this, and we have only one lone pair. So it contains two unpaired electrons, so it's already bonded. So we have this lone pair I am writing here. About second oxygen. So it also bonded with one, but it contain still more one unpaired electron. Okay. Okay, na? Next. What about third oxygen? So it's bonded, these two is engaged, only one. Okay. Then we need to write for 2s also. 2s ko bari pe kalwa, so it's also filled. So I need to mark it for this. Just a second, I'll rewrite it. This 1, 2, 3. Okay. I'll write it. Don't worry, Muhammad, I'll write. So 1, 2, 3. So two electron are already bond. Okay, so we have lone pair. These two, see the bond formation, so it's already bonds are present. So two electrons are present. Okay, here only one lone pair, that is 2px, this x, y, and z. 2px, one lone pair of electron is present. Comes to the second oxygen. So it's only one bond, so still it having two lone pair of electron. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Otherwise oxygen ಸ್ವಲ್ಪ confuse ಆಗುತ್ತೆ ಅನ್ಸುತ್ತೆ. I'll go with the water molecule. Are you understanding here? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಮೊಹಮ್ಮದ್ ಮಾತ್ರ ನೋ. Okay, Muhammad, you do one thing. I'll explain you in the zone of water molecule. So those who are understanding, please listen this. I'll just finish it off and I'll go for the water molecule. That will be easy to understand. So here, one lone pair, two lone pair, three lone pair we have. 1, 2, 3. Done. Next again, this carbon, it's bond with 2. By seeing the bond, so if one bond is present, one electron is shared. Two bond means two electron is sharing. One bond means one electron is sharing. Two bond means two electron is sharing from this side. So two electron is shared, already done. So you have only two lone pair. Okay, you have only two lone pair. So now we need to apply this formula. So see, this is lone pair of electron. Only lone pair of electron we are writing. Only lone pair of electron we are writing. So if you are with oxygen 1, so apply the formula. Total number of valence electron. Valency, how much you have? What is the valency here? 2 minus, sorry, it's not 2. The valency of oxygen, it seems to be 2, 4, 6. For oxygen, first oxygen we are talking about. You can't able to see.